Hi guys, how's it going? Today we're going to be looking at what I promised on Twitter a couple of weeks ago, which is to make a video around source generators. So they're part of a feature part of C#9, which allows you to look for a pattern in code and then generate code in part of your source code once it finds that pattern automatically for you. So you'll be able to just add a NuGet package, and then basically we'll have some injected code inside your source code. And this is useful for things like property changes, where they're very menial, glue-based code. You don't want to have to type gets and sets all the time with, like if property has changed via the event, all that kind of stuff. We can do that work for you automatically with the source generators. Now, in Reactive UI, we've already got a feature called Reactive UI property phodies. And a phody is just basically a way of generating IL code. They'll go through and similar concepts. So we've got the code here for the phody right here now. So what it does is it looks for code within the Reactive UI namespace, looks for iReactive object extensions. And if it can't find it, complains about it, which is actually a bug we have at the moment. Then it looks for an attribute above a property called Reactive Attribute. And then it goes through all the properties it can find in your project that have the reactive attribute above them. And so then I'll go through all the fields as well, and also constructors. And then it'll find the get method, and then it'll generate some IL code for you, which, as you can see, is quite complex and hard to maintain because we're having to deal with the assembly code effectively of .NET. So we're having to pass arguments and popping and returning values, and it's a little bit clunky. And for example, here you can see in the comments they're putting out the actual source code here. And the idea with source generators is actually just generating source for you rather than you having to deal with the IL code. So that's one of the reasons why we're looking today to probably replace our phody technique, or at least give you an alternative with the source generator technique. Obviously, you'll have to have .NET 5 to be able to access this feature. It's already out in preview. So once we get it up and running, you'll be able to go in and play around with it. And we'll put into a prototype project. So that's what we're going to be doing today. And Rodney's here to help out and call things out as we're going and stop there.
Yeah, I'm here today to kind of help, watch, learn, and point out things as we go along the way. We've looked at a little bit around how to generate these source generators and generate these attributes. So it'll be a learning experience for all of us.
Yeah, so we'll just go through the code in depth, or what's existing at the moment, because the logic will be roughly the same. So in Fody, when it's basically a compile time feature and it gets invoked as part of the compiler, and you get given a list of assemblies effectively. So we're interested only in the ones that start with the name of Reactive UI. So we want to make sure that the Reactive UI project is included. And then we just log some information about that. And we look for also the helper project that comes with the NuGet package for Fody. So that stuff we probably need to do this part of it. So that part will go away. And then what we do is we'll look for a Reactive UI object called iReactiveUI. And we go through all the types to make sure there is a derived class from the Reactive UI class. So we look for it. If we don't have something derived from my Reactive UI, then we can't proceed. And as I said earlier, that's actually a bug in that system. Some people are doing their own base classes and would like to be able to, we use extension methods to invoke the iNotify property change, and they'd like to be able to do it regardless. So that's something we could probably fix with the source generator, I'm hoping. So if we find that class, great, we go through then finding the raise and set if change method. So that's our extension method we have for raising iNotify property change events. And if that's not available, then we also throw an exception. And we also look for the Fody helpers assembly, and also a class in there called Reactive Attributes. So the Reactive Attribute is basically an attribute you put above your properties at the moment to indicate that you want it to kind of like be activated. So if we go in the test project for a sec, So you can see here we've got a reactive attribute that's set onto a property. The property is just an auto property, right? So there's nothing really to it, but the photo will go along and then generate a field called underscore property, for example, and also generate our setter for you. So we'll change this method to be called raise instead of changed. So that way it causes the iNotify property change events to happen. And see, it takes this very glue-like code and condenses it down to just popping an attribute on an auto property. But from our point of view, one thing to consider with source generators, they generate source. They can't modify code. Photos can modify IL code for you. So you can look for this and then modify its property. So we'll have to take that into consideration when we're designing our source generator, that we can't modify whatever we're generating. We can only generate new code. It's the way it's. Maybe I'd like it different, but that's the way they've implemented source generators. So then we go through and we found that reactive attribute, and we go through all the properties that contain that reactive attribute. And so we check to make sure it has a set method, because if it doesn't have a set method, we can't generate for it. And then we go and we create our field. So we put an ampersand in front and just put the property name in. We make it a private field, and we set the property type to be also the field type. And we add that. We generate a field into our code that basically the same as our property. And then we modify, we get our get method. So we find the get method for our field, and then we resolve it. And then we go through and find the constructor, and we effectively here we'll put in a field assignment. So we'll call, if it's virtual, we'll call it, or we'll set it to the default value basically. And then we'll generate a get method for that property. So we'll replace the one that's already there. And what we'll do is we'll say, hey, go off and call the, and get the value of the property name field effectively. And then we'll return that value out. So we'll take no arguments, we'll return a field, so the LD field, and we'll bind it to the target type, and then we'll return that value out. And then we'll also handle generic types. So we'll add the generics in here if we need to. So if our property is a generic, we'll make sure that we are passing that in. And again, we do a check for the set. And then we also do a set method as well. So the set method is no arguments. We'll get the value of the, we'll get the address for the field property. And then we'll get the value from the argument. So the value argument, and then we'll get a string for the property name, and then we'll call a method reference to our raise instead of change. So we pass in our property name, the value, and also the field as well. And then we call we don't care about the results from that, so we just call that method, and then we return out the method. So that's a little bit of clunky code with IL. It's not very human readable. Luckily, we've got these comments here, so we know what's being passed in. But if you're, if you're maintaining this code, it's definitely not the most readable thing. I mean, I'm a little bit lucky that I've done a little bit of this sort of code before, but if you're not used to it, I don't think, how would you go with this, Rodney? Would you be able to read this straight away?
No, I would definitely say this would take me a couple of iterations through, and I'd have to read through those comments a couple times to make sure that I understood what was going on. Because the reflection API is so diverse and so robust, it becomes very, very hard for people that aren't familiar with it to get in. It's a very big barrier to entry.
Yeah, and I guess also the big barrier to the entry on this is the fact we're not doing source code. We're actually just doing opcodes, right? And
Yeah,
assembly.
the assembly is another big turnoff. I've did assembly, long time ago, but not enough to remember exactly how to go about doing it. So the fact that we're actually having to emit IL code and not actually just build code, but change code that's already in existence, that's a little bit daunting.
Yeah. All right, guys, so we've had a short break and we've just generated this brand new project called ReactiveUI Property Chain Source Generator. And this is where we're going to generate our source generator from. Now you can see a source generator is just a normal .NET assembly, which is .NET Standard 2. The few little caveats though, we have to enable C# 8 features. So we have to change our lang version to 8. And we have to include some NuGet packages. So we have to include our Roslyn generator package, so Microsoft Analyze C# workspaces. So this is the package that'll include some of our source generator. And the other one we need to include is Microsoft Code Analyst analyzers. So let me just find the package for that and I'll bring it in. So that's now out of beta as well, which is nice. So we just included both of those there. And now we should find, if we go back to our generator class, we now have a property called generator, attribute called generator around. Let's see what happens. There we go. So this indicates that this class is now a generator class. So it knows how to handle generating source code, basically. And there's also a interface we need to derive from called iSourceGenerator, which is going to provide us with two methods that we need to handle. One is our execute, which will actually execute generating the code. The other one's initializing, so it gives us some information about the class and the ability to go through and sort of like bind stuff, I guess, is effectively what it's doing. So Microsoft's provided a sample already for generating iNotify property changes. And we're going to steal a little bit of their code from them. So one thing to consider about source generators is they work, you have to generate code. You can't work the old way with Fodi where you modify code. So part of that is we're going to have to generate the attributes for you. And so the first time you try to compile an application with this source generator in there, it won't exist. But as soon as you compile it the first time, it'll be available as part of your source code and you can reference it like we normally do. So we'll take this attribute text, which is just basically an attribute class that Microsoft's already generated, and we'll sort of like change it to our needs. So we'll have a ReactiveUI property change auto notify, and then we'll just generate one called reactive property attribute, for example, and we'll have to change the source code to say reactive property attribute. So as you can see, this is a standard off-the-shelf attribute, but it's just inside a constant variable here. So that'll just allow us to generate this for you, and then you'll decorate all your classes with this reactive property attribute, the properties inside of them to indicate, hey, we want to generate getters and setters automatically. One big difference though, and Rodney might have some questions about this, so we can't really generate from a property anymore. We have to go from the field. Any ideas why you think that might be, Rodney?
So if I had to guess, I'd say that the only reason we would have to do it that way is because we can't actually change, like we're not changing the IL anymore, right? So like Fodi changes the IL, so it takes code that exists and actually modifies it, right?
Yeah, that's right. So we can't modify it to, so in our previous example, we had sort of like, so we can't modify this gets and sets, but we can go from here, right? So we can say if it has a, what do we call it, reactive property. So if it has this property above it, we can say generate code for that. And what we can say is, hey, then generate our test property. So it's going backwards to what you used to, right? So it's going, going and generating the property rather than the way Fody would work is you put this above the property and it will generate this field for you, but also modify the auto property to reference that field and automatically call out methods. So because we're generating code here, we cannot modify existing code. But in this case, if we just keep it as a field, we can definitely generate a property for that. And it's something nice thing also about these generators is once you generated this code, there's nothing really stopping you from accessing IntelliSense or anything like that, which is one of my major concerns when I first started playing around this framework was like Fody code, because it's manipulating IL and happens after compilation. You can't use it as part of your code, right? So you have to have something that's automatically, that something that you can reference. So you would have to have that auto-generated. Well, you'd have to have this getter and setter here to be able to use it in your code. So, so you couldn't sort of like in the Fody case, because this happens after compilation, this already has to exist even though it's modified. So that's the limitation of Fody. In the source generator, because it happens during whenever you modify code in your code base or whatever, it will automatically this generated code that's generated behind the scenes, that method, that property will be available for you to access when you're typing and you're modifying your code. So that's one nice feature about this source generator technique.
So you're telling me that even though I don't have an actual public property anywhere in my code file using the source generators, I can still actually set up all of my iNotify property changes. I can set up all of my C# code bindings, and it'll be there?
Yeah, that's right. So after the first compilation, and because effectively what C# and Visual Studio is doing every time you're modifying code, and also Writer for people using Writer, is every time you're modifying code here and you're generating, it's actually doing quick compilations all the time behind the scenes. And that's how, like all these red symbols and all that kind of work. Like, like this is actually generating code for you for the IntelliSense. And so that's why it's going to be available as part of the source generating, like at design time as well. As soon as it's valid code, it will generate the code for you, which is really nice. And that's the way Roslyn analyzers work too. They effectively will interrogate the code all the time. So it's taking advantage of that type of technique in the background for you.
That's impressive.
Yeah, and certainly, like coming from a Fody background, it's certainly something you're concerned about, right? Because you always have to have actual functioning code to be able to access things. Fody just augment. But there's definitely advantages of the Fody technique as well, where it can modify code. Like it would have been nice, I guess, if I had had a modifier of a code. But the problem is they're just generating a partial class behind the scenes. So it would be a little bit hard for them to modify the code for you. It's just the way they're generating. So effectively, this attribute text and any source generated will be just in the obj directory of your project. And I'll have a .g.cs file on it. It's just generating source code. So your class will have to be partial that uses this. But that's why you can't modify code. But, given use cases like being able to, do notify property changes, providing you're willing to accept having a field, it's perfectly fine, right? So, yeah. So what I'm going to do now is also just copy some paste some code from the Microsoft sample. So what we're going to do is we're just going to say, this is a class we're going to provide called a syntax receiver. So effectively, we're going to say, we're going to get registered for changes to our source code from the user. So we're going to get told when the users change something on us, and we can kind of deal with that. So we'll have this class called a syntax receiver. And this gets told about changes in code, right? So, and we'll just have in here, again, we're just copying and pasting from Microsoft effectively. So we will have some field declarations that come in. So as part of our class, we're interested in fields, as we've already determined. And then this code does a little bit of reflection code here. So what it does is, hey, we get a syntax node coming in. So a syntax node is just a block of code, really, but it's been made into a nice class that we can interrogate, right? So what we're saying here is we need to know that it's a syntax field declaration syntax. And we also need to know it has an attribute. So we're interested in knowing if it's got this attribute being declared above. So what we're saying is just put this in our candidate fields, and this will get changed all the time, right? So this is where we get to know, hey, here's all the candidates, go off and read, basically. So now we can sort of like jump into we can generate our property class. So let's go and process our fields. We're going to copy paste a little bit from Microsoft again, just because they're fairly helpful to us. Because I've done almost the same code. We're going to stick with the style cop naming convention though. See how this is lowercase. We want to change this to uppercase, and we want to make it a private field. So this code here basically chooses a name for our field. So remember how in our attribute we had the ability to override it? If that's null, we'll generate a name for you based on the field name. Otherwise, we'll stick to what you specify, basically. So if we go back to here, you can see here our overridden name. So we have our type constant. If it's null, we just pick a name. Otherwise, we trim the start. So we're assuming that you'll have a underscore naming scheme, which is part of this common, like I guess .NET does it now. A lot of projects do it. And this is where, like we're making some assumptions about your code, and then we'll just go through and finding each, we'll just make it the first numeric there into an uppercase. So if we look at like, what it'll do is it'll strip that leading underscore and also make that leading character into a uppercase character, so that effectively we get this property instead of underscore lowercase this. So yeah, we're just going to choose a name for the user. And here's effectively how you can generate the code in the C# land, right? In the so I'm having to bring in a bunch of link statements and stuff like that. So effectively, we're going through, we had all those candidates, right? So we have a field symbol and an attribute symbol. So the field will be our, like when in our sample above, we had our reactive property above it, right? So this will be the field and this will be the attribute that we're matching in that method. So I'm working backwards, by the way. So I'm going from the field, then I'm working backwards to find all that candidates. But let's go through this code right now. So we're getting the attributes and we're going, it has to have symbol quality default. So that means there's no constructor in it. And we'll check to see if it's got a overridden property name value in there. So see in here how we have a property name parameter in here. So we might have that property name overridden. So that'll give us an overridden name parameter. We'll pass it into the choose name we just saw below. And then we'll get the name of our property. Hey, if we don't have a property name or a property field name, we'll just exit out of here. And see here from a maintenance point of view now, we're appending to our source, which is just a string builder. We're appending this C# code now. So in terms of this, we got our field type, our property name. We're just returning the field, we're setting the field, and then we're invoking our property change, right? So we want to change this to be not like this. We want to use our reactive type process. So we want to do what is it? Raise instead of change, right? And then we want to do, and we want to pass in value, and then we want to pass in the property name, right? So look at this. Now we're not dealing with, if we go back to the old Fody way, we were dealing with these IL statements all over the place, and just was hard to maintain. Now we're actually dealing with real life code, and we're dealing with, like we're just doing string replacements, right? And just interpolation. We're not doing anything fancy anymore. We're just going in, and we've just modified Microsoft's code. We might want to add a little check later on to make sure it's a reactive object, but like it's going to cause a compiler error anyway, right? If you're not doing that. So potentially this will allow more use cases for users. And it's just easier code to understand and maintain now because of this C# code that we're generating. Now, what we want to do also is we just want to go in and generate a class, right? So we're going to generate, remember how we're dealing with partial classes? We want to create a partial class now for our, to host these extra properties in. So this will live in your obj directory of your project, and it will have a .g.cs syntax on there. So again, we're just going to steal from Microsoft and bring across their code. So there's a few changes we need to make, but let's go through what they've got already. So they're saying it has to have a containing namespace, and it has to be, like we want a namespace for the project. So we're going to grab the namespace name, and here's where we're generating our partial class, right? So here is passing in an iNotify property change, and here is probably where we want to change it from a iNotify property change to a reactive object, right? Because we're not going to be dealing with, so we're just going to create a reactive object partial class now, which will give us access to, so it says if it's not already implemented, already add it. But in this case, we don't need to generate this code. This is already kind of already available in our base class, right? So I don't think we need to generate in this case. Potentially, the issue here is if people do their own iReactive object, they'll have to implement their own, like methods that implement everything. But they'll have to do that anyway. So for us, we don't need to generate that code. And then it becomes very like just normal code now. So we're going through all the fields available in the class, and we're processing the field, and then we're just going in and we're closing it off. So we're going, okay, there's one bracket there and then another bracket, and then we're just passing back the string, right? So we're generating a partial class from a reactive object, and we probably don't even need that base class really, right? Because from the user's point of view, you would specify that on the other side on the, like on your normal class, right? So you would probably have a class. Let me just do some pretend class. And so let's do a pretend what's being generated, right? So what's being generated is it keeps the same. And then it goes, so we have a field in here. So what the generator does now is we have to make sure our class is partial. That's the only caveat now, right? So that's one modification you have to make to your code to get this to work. But what we generate now is we go in and then we also do the setter now for you, right? So we do and we do and we pass in the value, and then we just do the name, because we don't have to do name of, because in our case the code already knows that anyway. So this portion here is what's getting generated.
So I have a question, Glenn.
Yeah, sure.
I noticed that you said that now the class has to be a partial class. For
Yeah.
somebody who's not as familiar with partial classes or doesn't particularly care for partial classes, is that a concern for that developer?
Um, most of it's a fairly common concept in C Sharp. For those who don't know what a partial class is, it allows you to have code for the same class to be in multiple files. Um, so this would live in sort of like in like a myViewModel.cs, and this would live under, as I was mentioning, in your object directory, and then it would be something like that, right? So the generator code that Roslyn provides will generate a class for us. For someone who doesn't like it, it's used a lot in C# land. Like if you're using XAML, so if you're using XAML forms, all your code behinds will be partial classes. If you're using Blazor and you add a code behind file, that will be a partial class. It's used pretty exclusively. And what's happening is these source generators, the concept of this generated code is not new. They're just allowing it to be more accessible to more users now. So they've been generating code for a while now, since the WinForms days, really, back in the mid 2000s. And this is just expanding the concept for you to be able to generate that code now, rather than being exclusively in the domain of Microsoft. So that's what I'd say there. So yeah, so far we've generated our base class. Now we just need to execute it, right? So again, we'll steal some code from Microsoft. And then I'll go through what they're doing. And I think we're pretty much done at that stage on how it works. And then we'll set up a little test project so we can see how it works, right? So, so what I'm going to do is we're going to change that to be that. And that'll be, okay. So they're going to add to our context. So we're going to add the attribute text. So that's going to be available always. So we haven't generated before, we just exit out, right? So we haven't registered for our syntax receiver. Don't bother, we can't do anything at this stage. And then we're going to pass C# code. So this is where it's going to get a little bit more advanced for those users who aren't quite used to C# code, this kind of reflection code. So this code here, we have to generate this property at some stage, and we always want to generate it once, right? So this is what it's saying. Just add that source code into our project. We'll live in that OBJ directory, and that'll always exist. But from there onwards, we have an auto notify attribute available, right? So this is kind of where we can do a bit more logic. So Roslyn provides this concept of a C# compilation. So at this stage, things are being compiled. It allows us to interrogate all the objects in our project. So we just use the standard parse objects and we just get our compilation. So we pass the source code for the attribute. So it knows what exists, and then we have to modify it so so it matches our code up here. So we've modified this. So we go in here and we grab that. So this will be the symbol now. We want to grab the symbol that matches this name. So we want to grab that reactive property attribute that we generated. And here is where the notify symbol is. And remember how we kind of decided, let's not bother with that. So because we have a reactive object, we could probably add some code in there later on if we need to, but given we already have bugs from users, but that's an issue, let's not do that for the moment, but we might add it back in if we're finding there's an issue, right? So, all right, so the rest of the code. So what's happening now is we loop over. So remember how we got this receiver? So whenever source code changes, it'll come in here and visit all the different nodes and add in all the fields where we got an attribute list above 0. So if it has any attribute above the property, above the field at all, so that has any of these attributes above the field at all will be picked up, right? So we have these candidates. Then what we do is we go through all the candidates that we found through the receiver. We get the compile version of this. So in Roslyn, you get two versions of code. You've got one that's the source code, and you get told about all the different elements of source code. So you get told this is a class declaration, this is a interface declaration. You don't get told about any of the context of that. So it's basically just a code representation of the source code. So it doesn't know about base classes, it doesn't know about anything else in the class. It effectively just knows about the source code. The other way of handling in Roslyn is a concept of compilation where you do the symbols. So the symbols know about base classes, and it's much more like regular reflection. So you can look for things that have a specific attribute. So here we're going through the compilation, matching up the syntax. So that's just where we only know, hey, here's a field from a source code perspective. And then we grab the semantic model that knows about the overall, all your C# files. And then we go through, we find the class, or effectively the file that field belongs to. So we get the semantic model, and then we go through all the fields that have been declared there. So we go through and we get the declared field. So now we have a symbol, which is really nice for us. So that gives us the ability to know about base classes, to know about derived types, all that kind of stuff. It gets the attributes and then matches any that matches the attribute symbol, so that reactive property attribute we have, and then invokes that into our symbols that we want to generate code for. And then it goes through and then finds all the symbols, and we now group them by the containing type, because we want to generate that code behind class, right? So, and we want to group them all based on those code behind types. And then we just call in this process class method we had before that generates our partial class for the code behind. And then we say, just add that source code based on the type to a, based on the class name, underscore auto notify.g.cs. So we can probably change that to a reactive notify. And then we just generate it from the source code. So we just say, here's the source code, generate it for us, please. And that's all that's involved with it. So let's do a little test now to see if this works, right? So let's create a test project, and we'll just do a .NET Core. And what do you think of this so far, Rodney, while I'm setting this up?
So far, this seems relatively straightforward. It seems like dealing with the Roslyn files, and because I'm dealing with compiled code, that it's a little bit easier for my brain to comprehend than it is for me looking at like assembly or trying to understand what's happening to change IO code. So instead of having to take the cognitive load of changing code that exists, all I have to think about is I'm adding code, which seems a lot easier.
Yeah. So I'm just going to regenerate that class as an X unit just to make it a bit easier. So we want C#, not Visual Basic. Okay. We'll correct that. Might want to update stuff because usually it's a bit behind. I think that's 2 now or 1. I think it's 2. We don't care about coverlet, and we might just add in ReactiveUI. We'll do this from just for the UI way, which users might be more aware of. So we add the Reactive UI project because that's what we're interested in generating for. So we'll install the latest version of it. We'll do our updates. Didn't like it. And we're out of dependency on the other one. One thing we'll have to do with our sample, right, is we want to be able to run our sample. And there's definitely a way of running it. I'm just looking it up now. Here we go. So the reference, if you're testing code and you want to run it in your tests, you can add this output item type as analyzer. And this just means treat it like an analyzer project rather than treating it like a normal include project. So this means all that generator code and all the analyzer code in that project will run rather than just you only be able to access the code. So now if we compile this, what's it compiling about? Oh, yeah. Generate too many. So now it's happy. So if we now go into our class, we make a pretend view model class. Let's see how we go. This is our first time running a brand new class, so we'll see how it goes. All right, so we'll make it public. We'll derive it off reactive object, like any normal, so like reactive UI project. And we'll call it, we'll make a private string. What do we call it? Reactive. Yeah, okay. And let's hopefully have it come up, otherwise we're going to be working out what's going on. Cool, welcome back guys. We had a little bit of a pause. So what we've done is we generated this unit test project that basically references ReactiveUI, which is the project we're interested in. Obviously XUnit, which, is, just a unit testing project. It's also doing a project reference to the source generator project we made. One caveat is it's using this output item type equals analyzer and also reference output assembly. So what this analyzer means is Microsoft's made this framework called the Analyzer Roslyn framework. That's been around for a little while now. They use it in Visual Studio and also Writer can use it as well, where it kind of brings up these little quick actions and a little light bulb. And what it does is it goes through and analyzes your code, and then if it finds a defect in your code or a improvement, it will basically bring you up a little light bulb and then analyzes that portion of code. And then once it finds it, puts into a list and then provides a fix. So Microsoft's hijacked this analyzer technology for its source generator. So it's very close. If you look at the way our reactive property is working is, like we're going through with our receiver and we're actually analyzing code, right? And then we're also analyzing code throughout this entire thing. So it's effectively just a plug-in to that mechanism. So we just need to tell it that this assembly is an analyzer. Otherwise, the C# compiler won't know about it. The other things we had to do was set up the net standard 2.1 is the minimum version now for the generators in our generator project. And also we just set our Lang version to be previewed, so it's the latest. I think you can probably use this on an early version of .NET. The samples I've seen around are .NET Core App 3.1, so you might actually be able to use this earlier. We just set up to .NET 5.0 on the preview just to set it up. And everything else is pretty much the same. So if we go, I've generated this view model class. I've called it my view model, derived it off the reactive object, which we were interested in. And if we go into here, we were interested in our reactive property, which has been generated for us now. So basically that analyzer's gone off. And if we go to the implementation of that, if we can, no, we can't. That's sitting in our obs directory now. So there's actually that partial class, which we specified here, that said attribute text, auto node property changed, you see here, it's popped that code in for us. So now it's available for us to decorate. And it's complaining about the missing partial. So it's actually generating partial class already for us. See how it was actually giving us an error saying, hey, generate a partial class. And now in my constructor, see how there's a property here now. Now, if we go to the property, which maybe I'll got us to do, unfortunately, no. That would be our generated code, but let's go to that code. I'm going to pause it for a second, bring up the... So now we've generated our project. So we've got our source generator. And now I've created this application project, single package reference to ReactiveUI, the latest version. It's using .NET 5 with a preview version of .NET, C#, sorry. And it's also got a project reference back to our normal project with a little bit of a extra item here called an analyzer. So for those not familiar, about 4 or 5 years ago, they had this concept of an analyzer to Visual Studio, and it's part of the Roslyn framework. It's basically a way of analyzing your code and finding defects. And then they'll just basically pop little lightning bulbs next to your code and little regular squigglies. And these are basically analyzers. So you can plug in your own analyzers. And StyleCop's a good example of this, or Roslinator, and the FX Cop analyzer that Microsoft released a couple of years ago. These are all good examples of analyzers, and they basically produce better quality code for you. And what Microsoft's done with the source generators is they've basically hijacked on top of that and effectively using that to kind of like generate these source codes. So there's a problem with the latest Visual Studio. This is actually working well with preview, I think it was 1 of this version. So 1.16.7.0 preview 1 actually was working fine with these analyzers. I've upgraded with to the 2 version, and it's sort of like showing you IntelliSense errors, even though this is working correctly. So if we compile this code now, it's working great. But I'll show you what we've done. So we've made this view model, derived it off a reactive object. We popped a reactive property above a field. And you can see here now there's a property called migrate field. And we've been able to set to a string. Now let me just make a new field. Let's call it migrate field 2. But let's call this one the IntelliSense error. So let's just give it a generic name, and so ignoring all the errors we're getting at the moment, let's hope the syntax is correct. We have no way of knowing. Yep, it's worked correctly. Now, if we just modify my output here, so we got my woo field, not woo field, and we'll just change it to a read line as well. And we'll change this to an exe. Do you remember the syntax for that? I guess it's output type of. So why is it not liking it? Oh, it's because we haven't set the startup project. So let's just change that. And can you see the output? Probably not. So the output of the application, just for those, just so you can see it, was actually, so if I just make a new little text project. So you guys at home can see what was outputted. It's a text file. The output was that. And let's just make it easier and we'll write this to a file, and then you can set a file, right? So it's not. But you can see from here, the properties are getting generated. We're able to access the fields, and we're not produced, basically from these fields, it's producing all this code for us. So once I fix this in the preview, which we'll report as a bug pretty soon, it's if you're able to deal with the fact that you're just specifying fields now instead of properties, it's definitely much more integrated into the Visual Studio environment, even though it doesn't look like it at the moment. What do you think, Rodney?
I think that the bug is definitely causing a problem, but I think that this overall approach is promising, specifically from a source generation perspective. Um, I think that there's a lot of things that we can do with this source generator.
Yeah, and one caveat here is definitely that source generators are in preview at the moment. They're definitely not production ready. We'll definitely have this available as a NuGet package, and I'm sure the experience will be much better pretty quickly. I'm hoping, my personal belief is, I'm hoping that this will replace most of the user's need for Fodi, just because from our point of view, the maintenance required for us is dramatically reduced. And also there's bugs, it's just easier for us to fix. At the moment, the Fodi is a bit of a, it's sort of, the guy who wrote the Fodi did a reasonable job for what's there, but if you look at other Fodis on the market, like the property change ones, they're much more comprehensive, have a lot more abstraction there. So it's just not just a huge block of IL code everywhere. It's just a lot easier for them to maintain and stuff, and has more features and stuff. And I think if we go for the source generator approach, it would just mean fast iterations on bug fixing for us. And there's also copyright stuff. If we're using a Microsoft project, it's just easier from us that we know Microsoft in general usually keeps a fairly consistent licensing and things like that for us. But we'll keep the Fodi around and keep supporting it. Just this will be an alternative that we'll recommend to users once it's stable. What do you think, Rodney? Anything else?
No, I think that covers pretty much everything.
All right. Thanks so much for tuning in. We've had fun producing this. Obviously, it's our first round of doing a source generator. What I'm hoping to do in the future is to see if I can expand this to get more performance out of things like the when any value stuff in the future. So I'm not sure if you guys know, but we've got a little incubator project called Reactive Marbles, which I've done a bit of work and then got bogged down with other work. And it's basically a way of us testing new syntaxes and all that kind of stuff without affecting the general population of Reactive UI. So I've done like a when any properties changed and when property values changed, things like that in that project. I'm trying to potentially do a lot of optimizations there. So with that version already, there's an expression-based project where it compiles into expressions when it's available. So you can't do that on iOS, for example, but you can on pretty much every other platform. So I'm generating compile code. So that way, when you're doing when any value changes, they will happen a lot faster. And also just simplifying the, when any values kind of evolved over time, and it's pretty, a lot of code involved in there. It probably can be simplified. So the idea of Reactive Marbles is just to provide an alternative with a new name when property value changes, and also just doing a lot of optimizations. And I'm hoping these source generators can have a place there with, getting around that iOS issue where you cannot have runtime compile code. If we can do it all in the compiler time, I'm hoping we can use this technology to speed things up dramatically. So look out for that sort of stuff in the future. We'll do more videos like this. We'll probably do one on just general features that we're implementing, and also just maybe we might notice that users are struggling with a certain feature, and we might start doing just how to use reactive UI. So thanks for tuning in, and have a great day, guys.